Hello everyone. I'm going to do a Reddit response video today. So this is a part that somebody on Reddit is trying to make. They are hoping to 3D print it, and it's looks like a bit of an oil gallery application. The way that he's gone about it, it's obviously not meant for machining or anything. They've actually started talking about this already. Someone's asked how do you plan on actually making this thing, because the question comes up because this is essentially unmanufacturable with traditional manufacturing methods, the way that he's got these grease galleries moving around, or these grease lines. I'll show the way that that I'd go about making these sorts of features for a 3D printing application, and also just talk through what I think when I see this design. So right now he's having the problem of, I think he said he's using the piping tool to cut these, and he's ending up with some weird artifacts here, which are, I think, just remaining bodies from using the piping tool or something. But anyway, first thing I'd say is that if you're doing this in 3D printing, I wouldn't worry too much about making the cross section of this whole circular, unless you're using the sides of the walls to support the top of the hole, which I suppose is fine. I'll make it happen with a circle cross section, but I'll go about it a bit of a different way than I think he has done it. Especially with these square bends in here, I think that there is an easier way to get around this. So what I'm going to do is kind of, I don't see this approach being that useful for actually manufacturing anything, but for doing what is here, I think this is probably the easiest way to get what he wants. So I'm going to quickly just make up something that half resembles what he's doing here, and yeah, I haven't done any prep or anything. I'm just gonna do this quickly. Before I move on, I see this timeline down here is a bit of a mess, but I know the guy who's starting this is new to the program, but yeah, just in future, just watch your timeline. Looks like you got some errors down here, and also you just got a whole bunch of feature deletes that typically you want to clean them up. I don't really like having a whole bunch of feature deletes in my timelines. So I'm just gonna start, and just gonna make a rectangular feature on the top plane here, and then he had what did he have? Rectangular feature, then like a parallelogram sort of thing going on. Make these two parallel, and then this guy vertical, and then what did he have? He had a rectangle with a rectangle cut out of the middle of it. So I'll make a rectangle here, and then he had another rectangle cut out of the middle of it. Oh, it was sort of more in the middle, actually, wasn't it? Like this. And then he had another bit that was notched out the end. So I know it won't be accurate to what he's done, and I'm not gonna fully dimension this thing. I'll just lock it all down. So that, yeah, why not? No need to lock it down, no need not to lock it down. But yeah, so then I'll modify this, and first thing you could do is you could, because you want to make this. It looks like he's got the looks like he's got his channels in the middle here, central to this body. So what you could do, instead of doing a whole bunch of extrudes and then finding the center plane, you could just do this as a symmetric extrude, in which case you already have your center plane, which is just the top or bottom planes. I'll do it this way, but I'll also show you how you generate a plane in the center. It looks like he's already done that, but yeah. So then you just would go mid plane and generate your plane like that. If you had extruded it away from the base plane rather than using that center extrude. So Actually, I'll do that just so it's super clear what you'd do if you needed to. So this plane and the top plane are on the same plane. This plane here and this plane here are identical planes, but I'll do it this way so it's super clear. So now, because we've got a plane in the center, and because he's got a round cross section that he wants to have, he wants to have it sort of interact at these sharp corners with also with a branch here. So the branch makes it a bit more difficult to use a bloody hell, I can't be forgetting the name, a sweep cut, because you got to have it follow the two paths. I'm not sure, maybe Fusion has a way of choosing a path and then repeating the action using a different path, but I'm going to suggest doing it a different way. And because this is circular, you get an easier option, which is, that's basically 4 radii. So I'm going to say, when you draw this, just start with your center line. So I'm going to just press L to start that drawing. Start on the center line there. I imagine this goes, there was a hole in the center in here somewhere. So let's say, let's just draw this hole just for reference. Maybe it would have already been there in the other design, but keep drawing my lines. There we go, and then I'll just repeat that. Keep drawing these lines over here. And then yeah, so that's going to be these are going to be all the center lines. So I'm just going to make them all reference lines, and then I'm just going to use an offset command on all of these to turn off this body. An offset command just so I can create both walls at the spacing that I want. You'll see what I mean. So say this was a 5mm diameter, 5mm diameter tube. Then I just do an offset. Okay. So actually, I shouldn't have made them all references. I'm just going to leave them as that's this construction line makes them sort of invisible, and the software doesn't use them as real features. They use them as sort of reference geometry to pull information for your actual construction lines. So now I'm going to make an offset of all these parts. I hate how it does that. Oh yeah, it only wants to do one at a time, that's fine. And then I'm going to say offset is going to be 2.5, which is half of the 5mm. And I would like it to do both sides, but it doesn't look like it wants to, so I'm just going to repeat it. And then I'm going to do the offset on the other side, so that's going to be negative 2.5. There we go. And then I'm going to grab this guy and do another offset. Offset this guy, 2.5. Then do another one, this guy, offset, minus 2.5. And also select him. So I hit the control key to be able to select other lines as well. So there we go. That's quite a bit of geometry there, and then I'm just going to show the body again. So now you can see I've got the tube in there, and I am going to now just generate a cut. So I'm going to I'll use modify. Could use create as well. I'm just going to turn off these bodies and go around and select all of my contours. They should all be selectable. Yeah. So this is showing that it's not a closed part. That's why it's white and not that yellowish color. So if I unselect this, you'll see it's that yellowish color. So I must have a gap here. There we go. Here's my gap. Okay. So I'm going to make this symmetric. Make that distance, total distance 5. Whoops. Total distance 5. Make it cut. But you'll notice that I'm still missing what that section there that I showed that wasn't that nice yellow color. So I've got to edit that sketch profile, and I'll make sure that that I have this all joined up. So I'll make these two collinear. There are cleaner ways to do this. I think if this wasn't just sort of a 3D printing application, I'd make it more clean. Maybe this line isn't horizontal or something, but I don't really care. Start that sketch. I'll edit this feature. Oops, wrong feature. Cancel. Down here, edit this feature, and then hopefully I'm able to select this now. Yes, I am. So there we go. So now we have the galleries all, there, present. And it's a square cross section at the moment. Yeah, so now I'm going to make it a circular profile. Sorry, that was my UE boom turning off. So then I'm going to make this easier. I'm going to make this slightly transparent, so I can see all the walls. And I'm just going to go in and select these. Start to modify these. Make that 2.5. You'll see that I start to get these curved walls. Now again, I know that this is not a great way of modeling this for an actual manufacturing engineering application, but again, this guy only wants it to 3D print, so I think that this is a fine way of doing this just for a prototype, just to check the geometry and the function. He had a note on there about this being for a motorbike, so I wonder if this is for oiling the chain or something, and this is going around some sort of sprocket or other, thing. So here we go, we're getting the oil galleries. I think once I get this done, this part of the video done, I think that this guy's going to have all that he needs to get this finished, but I'm actually going to show you what you would do if you wanted this to actually be manufacturable. If this was going to be a milled aluminium block, you couldn't generate a lot of this geometry. You couldn't generate these holes in here because your drill would have to get in here somehow, and you can't have drills go around sharp corners or even any kind of corner. So I'll show you a quick example of how I'd actually get this sort of functionality in an aluminium, in a solid, alloy block. But yeah, so to start with, that is the geometry that he wanted. It's got holes and their circular profile, and they're of the same diameter everywhere. I didn't use the loft command just because of the branching and the sharp corners that he wanted. If you were, someone mentioned on there that on the thread that he might be intending to mill two halves of this, so you'd have two halves of the, maybe I'll put them up on the other color, no, that doesn't work. Okay, so you could have two halves of this, mill out the channels, and then stick the two halves together, maybe with some sort of sealing gasket around the sides or something, maybe an O-ring, whatever. But yeah, so I'll show you how I would do it. So maybe I should turn this into a, I'll make this a component. Create components from assembly, and I'll call that 3D print example. So I'll hide that, and I'll quickly show you what I would do to actually generate something that you might actually be able to manufacture. So first thing is to know that when people manufacture like blocks for motors or crankshafts or anything that has oil channels in them, they often will use ball bearings to seal one end of the drilled hole. So I'll draw something that's like what he had. maybe even a bit more complicated to show what you could get away with. So yeah, so say that's no, I'll make it simple myself, make it quick. You'll be able to apply this to really weird geometry if you want to, but for the purposes of this video, I'll make this relatively simple. So say you wanted to have a gallery, this is an aluminium block, and you wanted to have an oil inlet here that came over here and came out two ports. So what you'd do is you'd drill your port here, have whatever your connection type is. Maybe it's a threaded connection, JAS connection, O-ring thread, custom arrangement, whatever you want. But you'd have your connection here, and then you'd start with a straight drill through here, and then you might want to have a hole come all the way through here, and then you want to have your two ports come out here. And there's no design efficiency in this. It's just the basics of how this thing could work. So I'll make this central again, symmetric I should say, and I'll make the block 10 millimeters thick. Oh, that looks really small. Okay, I'll make that a bit thicker. I'll make that 30 mil block. So first thing is I'd do a sketch to define where my hole is going to be on this plate. So maybe it's going to be in the center of this face. So I'd generate a point there, make that a reference. Usually it wouldn't be just in the center of a face randomly. It'll be, some distance from an edge or some mating face or whatever, but I don't mind. So I'm going to make a hole at point, single hole, and it's going to be on this face, and it's going to be at this point here. It's going to be a blind hole, and it's just a simple hole. I'll put a counter bore on there, why not? And the depth is going to be 30. The counter bore is going to be a 16 millimeter head. It's going to be 5 mil deep. This doesn't matter at all, and the diameter is going to be a 10 mil diameter bore. I'll make that deeper, make that 50. So this is a drill hole that obviously it would be, make it deeper, it would be quite, easy to understand how someone might actually make this body. So opacity control, I'll make that just a tiny bit clear so I can see all of this. And then I want to be able to bring this oil all the way back down to here. Now this would be a really tough drilling application to do a drill hole this big, but we're doing it. I mean, a drill hole this long, you need a whole, almost gun drilling setup to do this sort of thing. These oil galleries can be really hard to manufacture accurately, so I'm going to edit that profile sketch, and I'll redesign this so that I have a perpendicular line that comes towards here. So I'll just make these perpendicular to each other. Yeah, so this is going to intersect with that line I saw before, so I'm just going to stop that. And so now I can make a hole on this face here. So I'm just going to look at that face, and I'm going to make a sketch on it that that interfaces relatively well with this hole that I've made previously. So I'm just going to make a point actually. Sketch a point, and it's going to interface right in the center of or maybe I'll make it just be coincident with that, just so that I know that it's going to interact. So stop that sketch. I'm going to make a hole on this face right there, and I'm going to make this a really, really long hole. So again, this would be a really challenging drilling exercise, if it's even possible at this length and diameter, but that's okay. And generally you would make you don't want to have too tight control, if you don't need to, about how deep you drill a hole. So you generally, if you can, you'd over drill just a little bit. on both of these actually. Both of these could be going past each other quite happily. And then what you do on this end, instead of having a small, counter bore like that, you might choose to have a much larger counter bore depth. So that counter bore might be 10. Oh no, if we make that 16, then you could easily punch if we make that you make that an interference diameter. So say that's, I've never designed one of these before, but say you made that 15.95 millimeters in diameter, and then you took a 16 millimeter ball bearing and you hammered that in or pressed it in, then you'd have a nice seal on the end of that drilled oil line. And then you do the same thing here. You'd generate one of these lines on this side. Actually, you could drill straight through. So say you wanted them in line, just make a hole on this plane to find its location better than I just have. Drill it all the way through, and there you go. You got your 2 oil galleries, and you have a seal on this side. So yeah, and then make your connections, whatever you need. But yeah, so essentially you could, if I hide this and turn back on this original one, hide the sketch. That looks a bit weird, the opacity. Let's just turn on wireframe. So say you had, it's because my fillets fell over on that one. Oh well. Say you had I'll fix it quickly. Why not? New feature. There we go. Say you had you wanted to create all of these tubes exactly as they are, but in a way that's actually manufacturable. You'd have to use a whole bunch of plugs. So you'd drill this partially deep, that's fine. You'd drill this one from the edge here, that's fine. You'd plug the end of it. You'd drill this all the way back from this side and plug the end of it. Then you'd drill this, probably I'd say from this direction, and then plug it here. You'd drill this all the way through and plug it on both ends. Then you drill this side, plug that, drill this side, plug that, drill this and plug both ends. Obviously that's way too many plugs. Like I would say you'd probably want to design in a different way to generate this. Maybe use external tubing rather than a block of this stuff. A block with channels through it if you need to achieve all of this sort of complexity. Maybe even just some hoses. So you'd make a mount here with a connection for your hydraulic fluid or your cooling fluid or oil or whatever it is, and then use the fact that this is a hard block to then put another port on the other side and run some flexible tubing along the outside, and then re-inject the fluid at another nice rigid connection point. But yeah, this is a pretty the guy only wants to 3D print it, so all good. But yeah, there's probably going to be other ways of doing this for the final piece. But yeah, hopefully that's helpful. If you want to do way more complicated, completely curved designs, then you'd definitely go for the swept cut route, or there was a great video that was put out by a couple of channels on wires in Fusion 360, which would be a great way of making, instead of doing a swept extrusion, you'd do a swept cut to generate, fully customizable 3D sorts of cylindrical shapes like these wires. Yeah, so I'll put a link to this video in the video description, but that was a pretty long-winded explanation about how to do something that you probably wouldn't end up doing for manufacturing. But yeah, hopefully that is helpful for the guy who needed it. Yeah, thanks. Thanks for watching. And I'm going to make another video about that skateboarding application. So if you want to stick around and watch another video.